Hello everyone, thanks for stopping by. So in this video, we are going to take a look at solid edge mold tooling and the various functionalities which are available within the solid edge mold tooling application. So to start working on solid edge mold tooling, we have to start with the blank assembly, define our project, and then set up the component with the parting lines and the surfaces, and finally generate the mold base. So we will do all of that in this video. There are much more additions that you can do in the mold base, which includes the likes of standard parts, cooling circuits, injection channels, etc. that you can also do. Much of the information is also available within the application itself, but we will start with a quick introduction first. So I'll create a new assembly, and this can be a completely blank one. I don't really need to import the component first because it will get imported automatically as I start creating the project. So I'll click on create mold tooling project, give it a name, define the location for this project, define an orientation, choose the units, and click OK. I'll select the part here and it will automatically bring this part in my current level, which is my assembly. I can define the shrinkage for my part, and since this is uniform, it will be set for all the directions. I can also change the orientation in case my part is not oriented around z-axis. Notice how the regions are also automatically detected by solid edge mold tooling. So I'll click finish, and as I move from left to right, notice there are different steps which are available for me, and whichever ones are applicable for the current component, you can use those and skip the other ones. So there are some steps which are mandatory, like generating your parting line and surfaces, and then there are others which are optional, like creating slides. So in our case, we don't have any undercuts, so we will skip the slides part and we will directly generate the parting lines. So in this case, we will select our part and accept the selection. Notice how solid edge automatically generates the parting line from mold tooling application. And yes, this process is pretty automated, and same thing happens with the parting surface as well. We just select the part and let solid edge do all the heavy lifting for us. Notice how these surfaces are created automatically at a separate part, which is called parting zone. And if we are satisfied with the surfaces, we can accept, or we can make changes here in this step as well. We will have various controls to manually edit the surfaces also if required, but we will finish for now and move to the next step. So once our parting surface is generated, you have to define the parting zone, which is basically to create the core and cavity inserts. So I'll select the part again, and then I have to define the dimensions for my core and cavity insert. I can also choose the template. Basically, it defines whether the core and cavity will be rectangular and or circular, and then I can also define the dimensions. So I'll select an opening point first, and then I will go to the dimension step where I can define the overall width, length, and the height for my mold. So I will change the values here. I'll set the X, Y, Z values, and if I have not kept the two values equal by turning this checkbox off, I can keep these values different. So for my injection, I have a 40 millimeter height plate, and then for ejection, I have a 20 millimeter plate. I can also add fillet if required, but I will select OK and click preview. So this will automatically generate the core and cavity blocks. And again, this process is also automated, wherein solid edge will automatically trim these two plates as well around the parting surface and also do the Boolean operations, which will be evident in the next few steps as well. But for now, the core and cavity layout looks good. If we have to review any one of these, we can do it at any point. Notice the cavity getting created, and also the entire layout with the parting surface. So we will show everything again. And now if we are needing a patterned cavity, which means maybe we will need a multiple count of the same core and cavity instance, then we can do the pattern also. We simply have to select both the core and cavity instances, define the total count in x and y. We can give some spacing, or we can make it 0 so that there is no spacing between the patterned instances. These will be automatically centered, so we don't have to worry about the plates not getting positioned correctly. We can also rotate the individual occurrences if required and create runner bars also. But for now, we will simply accept the defaults and click finish. So Solid Edge mold tooling will automatically create the pattern and give us the final layout with the correct arrangement. And in this case, you will notice that the coordinate system is still located at the center and the plates are adjusted accordingly. So the blocks are adjusted accordingly. And you have a slightly darker one which indicates the parent core cavity, and the brighter ones indicating the patterned instances. So we will turn off the coordinate system and we can move to the next step, which is to create the integer plate that will encompass this pattern. So we will go to parting zone, select the integer plate, select one of the instances here, it will automatically choose everything. We'll click preview. This process is again very automated. Most of it is in fact automated, and we will simply click finish and it will do the rest of the work for us. Notice how the integer plate is automatically generated now. And finally, we have to create mold base. So for mold base, we will select our standard. We can choose any one of the default standards which are available within our library. I'll choose the Haskell standard. I can select type. I can define a description, choose the series that I need here, and some additional properties such as the plate types, etc. And once I'm happy with everything, I can select the size which is most optimum. Though Solid Edge mold tooling automatically picks the right size, we can certainly change if required. So maybe in this case I will pick 296 by 346, and if I need standard parts to be added in the mold base, I can turn it on. I can also select the dimensions of some of these standard parts if needed. So I'll click preview now, and this will automatically create all the plates. Now this is the best part within Solid Edge mold tooling, where we are not bothered about the structure. We do not have to in fact create the structure manually. But once this is finished, you will notice how the entire Pathfinder gets populated with the components. So I'll click on finish. It will automatically generate the holes. It will do the Boolean operations. It will place the parts for us. It will do everything. So we don't have to spend time creating our mold base, which is a very repetitive task. I'm sure you will know. So once this is created, we will review the Pathfinder and the entire assembly structure that is generated for us. And on the right hand side, we will also review the mold tooling Pathfinder, which points out all the components that are generated. Through mold tooling Pathfinder, we can also go back to any step if required. So it's just like any other Solid Edge command where we can do edit definition and make changes, because this is all parametric and associative. So if we make some changes in the first step, the remaining ones will also get updated automatically. So it's not a one-off thing where it's generated and we cannot do anything. We can make changes to the parent instance, let's say parting zone or maybe a parting line also, and then the rest of the things will get updated automatically. And we have our Pathfinder with all of the components located here on the left hand side. Now if I have to place additional components, I can also add more from my library. Maybe in this case I will demonstrate by adding some locating rings. I will add one locating ring here. So I will choose one standard locating ring which is available in the library. I will choose the dimensions. I'll keep the default for this case, but depending on the availability of the parts, we can change the dimensions. Now my locating ring is slightly generated inside the plate. but we can offset this value in z direction if required. Let's keep it as is. We don't really need to make any changes here. We can also add more components. Let's say I'll go to injection, and this time I will choose injector. So I will add one uh, injector here with Z51 characteristic. I can choose the exact component from the catalog, and again you can see various components being available here. I will choose a right fit, which would probably be an ideal component for this case. So the length may be slightly smaller. I can go up to any limit I want. I can also change the dimensions at a later point if needed. And because the dimensions are arranged as per the catalog, I have exact match, and that is exactly placed in my current mold base. But I can change these values and play around and place the exact component that I need. I can also control the placement, which basically allows me to select the plane where this part will be located. I can add offsets, and same thing is valid for all the other components that we will add to the mold base. And these components can further be patterned if required. So we can, let's say if we are adding some ejector springs uh, in one of the sides here, in one of the pillars, we can pattern it on all four pillars very easily through the pattern command. So we don't really need to place all these springs one by one. And same thing happens with other components as well. Likewise, we can create cooling circuits. We can also create injection channels if needed. But for now, I think our mold base is somewhat ready. We can also look at other functionalities in the coming videos if required, and if any one of you has any specific questions on those, please feel free to drop your questions in the comments, and I'll be more than happy to answer those. Lastly, since we are doing all of this in latest release and the greatest one, Solid Edge 2023, so we have a lot of functionalities. We'll go to Visual Explode and quickly do a Visual Explode. So I'll zoom out slightly. See how this entire assembly gets exploded, and we can visually see the entire uh, set of parts in sub-assembly is getting exploded. We can review all of these parts. Notice how the cutouts are created. Our core and cavity blocks are also generated with the standard parts, and we can add more parts to it. But I think to begin with, this should be enough for anyone who is looking at understanding the mold tooling functionalities within Solid Edge. So thanks for watching this video. Stay tuned. And as I said, if you have any questions with respect to mold tooling, please feel free to drop those in the comments. And I will see you in the next video. Thank you very much.